Hello everyone, welcome to Smart Farm Insight. Across the world's vast oceans, there is one creature whose life story stretches farther than most ships ever travel. A fish capable of swimming non-stop for decades, crossing entire oceans without rest, simply because it must keep moving to breathe. That is the tuna, the unstoppable engine of the sea. Sleek, warm-blooded, and built for speed, tuna slice through the water at nearly 75 kilometers per hour, leaving most ocean predators far behind. Yet as extraordinary as its biology is, tuna's greatest influence is not in the wild, but in the global economy. From the open ocean to fully automated factories, tuna has become one of the world's most valuable and widely consumed seafood products. Today, we break down this remarkable journey into 10 milestones, each one revealing a part of the sophisticated chain that transforms this ocean racer into the canned tuna on millions of tables worldwide. The journey begins long before any fishing vessel leaves port. Tuna follow complex migration routes influenced by temperature shifts, prey availability, and ocean currents. Fleets study satellite imagery, sonar readings, and historic catch data to predict where these fish will appear. During peak seasons from May to September, the Pacific, Atlantic, and Indian Oceans become highways of movement. Skipjack tuna, the backbone of the canning industry, gather in massive schools large enough to be detected from the air. These patterns guide fishing vessels toward the richest and most sustainable harvest zones, minimizing wasted fuel and maximizing efficiency. Once a vessel reaches the target region, the search becomes more intense. Spotter planes and helicopters sweep the horizon, scanning for surface disturbances, shimmering shadows, or flocks of seabirds, all signs that tuna are feeding below. Meanwhile, onboard sonar systems map the underwater landscape, detecting schools hundreds of meters deep. This combined approach reduces search time dramatically, ensuring the vessel can act quickly while tuna are still concentrated. The ability to locate a school can determine the success or failure of an entire expedition. With the school identified, one of the most dramatic moments of the entire operation begins. The vessel deploys a purse-seine net, a floating wall that can stretch for kilometers. The net forms a giant circle around the school, gradually tightening as the vessel maneuvers. At the bottom of the net, a rope called the purse line is pulled shut like the drawstring of a bag, preventing the tuna from escaping downward. This method allows fishermen to harvest enormous quantities in a single deployment, making purse seining the most efficient method for skipjack tuna destined for canning. Once the school is secured, cranes and powerful hydraulic systems lift the dense mass of tuna from the ocean into the vessel. The deck erupts with movement, hundreds of fish thrashing at once. Crew members work quickly, rinsing the fish with seawater to remove slime and blood. Sorting happens immediately. Prime quality fish are separated for fresh markets, smaller and medium fish are destined for canning, and damaged fish are discarded. The tuna is then rapidly cooled in refrigerated seawater tanks or packed under crushed ice. Without rapid chilling, the meat can lose its bright red color and firm texture within hours. Cooling stabilizes the flesh long enough for the journey back to shore. Once the vessel docks, the tuna is transferred into insulated trucks designed to maintain low temperatures. The fish is then transported to giant storage facilities where it is frozen at temperatures between 18 degrees Celsius and 25 degrees Celsius. At the processing plant, one of the industry's greatest innovations takes over, cutting tuna without thawing. Still frozen solid, the fish is fed into massive cutting machines capable of processing up to 1 ton per hour, slice through the frozen flesh with surgical precision. Processing tuna while frozen offers several advantages. prevents the meat from becoming mushy, minimizes fluid loss, reduces discoloration, and limits microbial contamination by up to 80%. For larger species like yellowfin or big eye, specialized artisans manually cut the fish using long, razor-sharp knives. Their precision can determine thousands of dollars in value. Many are paid salaries equivalent to high-level engineers. The next milestone is cooking. Tuna portions are loaded into towering industrial steamers, capable of handling tons at once. Temperatures are carefully controlled, so the fish cooks evenly without drying out. This steaming stage enhances flavor, firms the texture, and prepares the meat for separation. After steaming, the tuna enters the manual filleting area, a zone requiring exceptional skill. Workers separate bones, skin, and connective tissue entirely by hand. Thick gloves are avoided because they reduce precision. Every usable piece of meat is sorted into premium chunks or flakes, depending on the product type. Now comes the stage that defines the final product, canning. For solid tuna chunks, workers manually arrange each piece inside the can in a specific orientation to ensure it appears neat and uniform when opened. This is especially important for mid-range and high-end products. For flake tuna, workers distribute the meat evenly to ensure accurate weight. Next, preserving liquid is added: brine, oil, or custom sauces, depending on regional tastes. This liquid prevents oxidation, enhances flavor, and maintains moisture during long-term storage. After filling, the cans are sealed using high-speed seaming machines that crimp the lid tightly to create an airtight barrier. Sophisticated sensors monitor the seam in real time, detecting even the smallest defect. Faulty cans are automatically rejected. The sealed cans then enter sterilization chambers, steel vessels that use high-pressure steam at 121 degrees Celsius for 60-90 minutes. Sterilization eliminates all harmful microorganisms, ensuring the product remains safe for years. When sterilization is complete, the cans are rapidly cooled to protect texture and maintain quality. Only after cooling can the tuna move to the final stage. The final milestone brings the entire process together. Cans are grouped into sets, wrapped with printed carton sleeves, and sealed with shrink film to create stable, transport-ready packs. Barcodes are applied for inventory and tracking, and the packs are stacked onto pallets before undergoing another layer of protective shrink wrapping. From here, the pallets enter refrigerated shipping containers and begin their global journey, heading towards supermarkets across the United States, Europe, and Asia. Each can represent a system of fleets, factories, and workers across 3 oceans. A product made possible because of coordination, technology, and the relentless journey of the tuna itself. From deep ocean hunters to high-pressure sterilization chambers, tuna undergoes one of the most complex transformations in the seafood world. Each can of tuna is the final chapter of a story written by fishermen, engineers, factory workers, logistics teams, and decades of industrial innovation. Behind the simplicity of a single can lies a global ecosystem of effort and the incredible journey of a fish that never stops moving until it finally reaches your table.